Hello, today I'm going to talk about global conveyor belt and go over the lecture here. So this first image actually shows the global conveyor belt, and this is a very, very large scale movement of water, so a large current. And you can see that there's either warm current, which is on the surface, or there's a very cold current that is on the ocean floor. And it only sinks in one area up here near Greenland, and it rises in two areas up here. So this is the biggest movement of currents. The largest scale current of ocean water is called the global conveyor belt. It is a continual loop of warm water at the surface and cold water at the ocean floor. We take a closer look here, and it shows the Gulf Stream going by the USA. And this Gulf Stream is on the surface, so it's warm. But you'll see that this is the area that once it loses its heat, it's going to start to sink. The warm Gulf Stream current carries heat energy to Europe. So this heat right here keeps Europe from freezing over. It actually keeps it a warmer climate than it normally would be, being so far north. The warm surface water eventually sinks near Greenland right there. And we'll talk about what's happening with that area next. So at Greenland, the Gulf Stream has used up a lot of its heat. It's given off a lot of its heat. Some of the water starting to evaporate, and both of these things make it less dense, so it wants to sink. So saltier water and cooling water is going to sink. And that happens up here near Greenland, where it's pretty cold. You're getting towards the Arctic Circle. Well, that really cold, dense water, because of features of the ocean floor at a spot right between Greenland and Iceland, forms this waterfall as this cold, dense water fills up this basin and then eventually overflows that basin. And this cold water sinks and moves along the ocean floor. Well, that water leaving and going over this waterfall pulls more of that warm water down. So that's what keeps the cycle going. This is because it starts to cool down, gets saltier, and becomes more dense. This waterfall pulls more of the warm surface water towards Greenland. And then we're back to seeing the whole conveyor belt. The cold, deep ocean water eventually ends up in the Indian and the Pacific Ocean. It starts to warm up and rise towards the surface. So the Indian and the Pacific aren't as deep as it was over here. So now it starts to rise up, heats up a little bit, and will start to actually rise up to the surface. Again, this is all one loop. Okay. Now back to Greenland. Greenland is covered with ice, but because of climate change, that ice is rapidly melting, more than it has in the past. As more glaciers in Greenland melt, more fresh water is dumped into the North Atlantic Ocean. So all these areas where we have melting along the coast of this big ice sheet dumps fresh water. This is not salt water, right? Because glaciers or ice are just pure water, not salt water. The problem is, by dumping pure water in, you actually make the ocean water less dense, and it's not going to want to sink. This decreases the ocean water density and slows the global conveyor belt. So now that big loop we were talking about starts to slow down. Slowing the global conveyor belt could have many negative effects, including a colder climate for Europe, a hotter climate at the equator, and far less nutrients from upwelling. So this is the process of upwelling, where this cold, deep water comes up to the surface. That can happen on a local scale, like along the California coast, or on a large scale, like our global conveyor belt in Indian Ocean and Pacific Ocean. But it's important because it brings nutrients for the base of the food chain, like your planktons. Okay, so I hope this helped. Let me know if you have any questions. Thanks.